Welcome to my channel, Dhanesh here. Today I am going to discuss about speech recognition systems. Let's start. Automatic speech recognition systems accurately translate spoken utterances into text like words, syllables, etc. Examples for automatic speech recognition systems are YouTube closed captioning, voicemail transcription, diction systems, Siri frontend. These are all examples for automatic speech recognition systems. Why we need ASR systems, automatic speech recognition systems? Speech is the primary means of human communication. It helps us to develop natural interfaces for both literate and illiterate users. Speech recognition contributes to preservation of endangered languages as well. Next, we will discuss about the history of speech recognition. In the beginning, we used hidden Markov models. After that, we started using deep neural network based systems. Markov models, the Markov chain was one of the first algorithms used for language generation. This model predicts the next word in the sentence by using the current word and considering the relationship between each unique word to calculate the probability of the next word. In fact, you have seen them a lot in earlier versions of smartphone keyboard, where they were used to generate suggestions for the next word in the sentence. Next one is the deep neural network. You are familiar. A deep neural network, DNN, is an artificial neural network with multiple layers between the input and the output layer. Deep neural networks are used in different ASR systems. This is the architecture of ASR systems. There are different modules are there: acoustic analysis, pronunciation model, acoustic features, decoder, acoustic model, language model. This is the complete architecture of the ASR systems. These are all the modules coming in this, ASR systems. Acoustic analysis. When we talk about acoustic analysis here, the raw speech signal are converted into discrete sample. Each of the sample is in the order of 10 to 25 milliseconds of speech. The samples are known as speech frames. It is assumed that within each of these frames, the speech signal is stationary and features can be extracted. Next module we discussed is the acoustic features. The features are extracted from the discrete sample, that is the speech frame, right? Here, a lot of signal processing is involved. It is motivated by how our ears work. For this signal processing, we use Fourier transforms. Next module we discussed is the acoustic model. Acoustic model creates the basic unit of phoneme from feature. Phoneme is a discrete and distinctive unit of a language that can be used to differentiate between words. Most language has 20 to 60 phonemes. We are using hidden Markov models as acoustic models. Currently, we use deep neural networks as acoustic models as well. Next model we discussed is the pronunciation model. This model provides link between phonemes and the word. Typically, a simple dictionary of pronunciation is maintained. This is the only model which is not learned from data. All other models are learned from data. I believe these are all the one more model is this is the important one, that is the language model. See, language models used primary for the first function of language model is how likely is it for different words to occur given the recent word context. The next one also used to distinguish between similar acoustics, or it is also used to disambiguate between similar acoustics. Popular language models we use, the toolkits we are using for language modeling are SRILM toolkit, CanLM toolkit, OpenGram toolkit. Nowadays we use RNNs, recurrent neural networks based language models as well. Next, we will discuss about the applications of language models. Next is the applications of language models, that is speech recognition. That is one application of language model, machine translation, handwriting recognition, optical character recognition, spelling correction. These are all the applications of the language models. The next component we have to discuss is the decoder. It is the most important component. Now we have estimates of phoneme sequence, word sequence from different ASR systems. Now need the proper word sequence for the speech utterance. Here it is a search program. Here we use search graphs using hidden MARKOV models. Next, we are discussing about the implementation using Python speech recognition package. The speech recognition library acts as a wrapper for several popular speech APIs and is thus extremely flexible. One of these, the Google Web Speech API, supports a default API key that is hard-coded into the speech recognition library. Next is how we can install speech recognition. There is a spelling correction in the speech recognition. Sorry for that. It is better to use Python 3.3 plus. Then you can use the pip install speech recognition. Then we need PyAudio. So for that you can use pip install PyAudio. If you are using Anaconda, see, you can use conda install -c conda -forge speech recognition and conda install PyAudio. This recognizer class is the heart of the speech recognition. You need to import that class, import speech underscore recognition as SR, and after that you need to use the recognizer method. When you are working with audio files, use record method to capture data from an audio file. When you are working with microphones, you need to use pip install PyAudio. Otherwise, if you are using Anaconda, you can use conda install PyAudio. Here we use the microphone class and listen method of recognizer class. For that, we will get into the code. See, as I told, I am using, this is the audio file I am using. I will just play it. This is a 30-second audio file. This is the audio file I am using.
The birch canoe slid on the smooth planks. Glue the sheet to the dark blue background. It is easy to tell the depth of a well. These days a chicken leg is a rare dish. Rice is often served in round bowls. The juice of lemons makes
This
wine
text
punch.
only we are
The
converting.
box was thrown beside the
This
pork chop.
audio only we are
The
converting
hogs
into
were fed
text.
chopped corn and garbage. 4 hours of steady work faced us. A large size in stockings is hard to sell.
So you can see this audio file I have saved inside decolon tatumasi speech recognition. So this is the audio file. This is the file I am using. You can see it here. And after this, see, as I told, I am using the anaconda. See, from his, when you type spider, you will get the IDE, spider IDE. So I have the spider. This is the IDE I am using. So in the program, it's here. It is, we have to first import speech underscore recognition as SR. That speech recognition, that package, it is, imported. After that, you have the audio file. The location I have given the audio file as I have shown in the local system. It is decolon tatumasi speech recognition audio. That file I have, it's here. After that, from we have the variable r. It is sr dot recognizer. I told recognizer is that class is the main class. We have to use it. Most of the methods like record, listen, all these methods we will get from the recognizer class. So I am trying to get an instance of the recognizer class by using the speech recognition. After that, I am using this piece of code with sr.audio file. It is, I pass the audio file as source. Now I can use this source everywhere. So audio is equal to r.record. Record is the method. As I discussed, I am using record method since I am recording from an audio file. If you are using your microphone instead of record, you can use listen method. Listen, I discussed there is the difference. If you use listen method, you have to talk. You can you can use pi audio, you can install it, and you can you know you have to talk and it will be converted into text file here. After that, I have included the try except block to catch the exception, because sometimes if it is not working, we have to catch it. And it is, if it is not working, it is given could not request results from Google speech recognition. That piece of code is also, and we are the exception, the instance of the exception is also created here. So this is a simple piece of code written in Python and by using the speech recognition package. So let's run it. I will run it. I have already run it here. I am doing it once again. So you have heard the audio file previously. You know what it is there. So I am running it again, this piece of code. It will take some time. We will wait for that. So you can see here it will come again. Yeah, it came. So the audio file contains, see here we have written the audio file contains and r.recognize Google. So that method only calling here, recognize Google method. So the perched new shift on the smooth bikes seat without play background editor with observable 30 days it takes. So the whatever audio I played, the same sentence you can see it here. So that's all about the speech recognition. So I have used the anaconda here. You can see the anaconda prompt here. So this is the on top of that only I am installing Python. Even you can install TensorFlow, Keras, everything you can install on top of anaconda. Here I am not using any other tool, TensorFlow or Keras. We are just using Python 3.1 or later version of Python, and the speech recognition package only we are using. So you after that I can get spider this IDE from Anaconda and you can run it. That's all for speech recognition. Thanks for watching. Please subscribe my channel.